School's back in session. We started off with a review of EKGs, ECGs, the 12 lead ECG, proper placement, the creation of standard limb leads 1, 2, and 3, your augmented leads AVR, AVL, and AVF, and then the precordial leads V1 through V6. We did go over the correct placement for those. Happy to do that in a separate interview, but we're moving into mechanical ventilation. So we're utilizing pill beams, mechanical ventilation, and we started with chapter 1. In there, we've progressed to chapter 3. My group will be having their first 50-question multiple choice MBRC style exam on Monday when they come back. So this is just to kind of review some of the information that we've gone over. So we do have a ventilator. I'm going to show another ventilator here in just a moment, but here we've got the Servo U ventilator. On these ventilators, they utilize a dual limb ventilator circuit. So you'll notice there's an inspiratory limb and an expiratory limb. So from the machine, air will travel through that blue piece of corrugated tube in there out to the patient. We'll get to the patient Y. You notice we've got a Ballard inline suction catheter and or just an inline suction catheter, and we're utilizing an artificial nose heat and moisture exchange, or however you may do it. And we've got to do that because with an endotracheal tube, we're bypassing that upper airway. We also have our electrical plug, and remember, those need to be plugged into an outlet or a red outlet that's noted to be on a backup generator, because these things do have internal batteries, but if we're only working on the internal battery, then we can only ventilate for the life of the battery. So it makes sense to be plugged into an outlet that is on a backup generator. Additionally, we have our oxygen hose, that's the green hose you see there, and the air hose. Those are our 50 psi gas sources. Those will hook up to your diameter index safety system outlets on the wall. And that's going to provide you the ability to give an FiO2 or provide a fraction of inspired oxygen, or at least deliver a fraction of oxygen to a patient between 21% and 100%. So we should hopefully be able to guarantee an FiO2 anywhere between 21% and 100%. We talked about the difference between a dry circuit and a wet circuit, or heat and humidified circuit. So what is set up here is a dry circuit, meaning that we are utilizing that artificial nose. And remember that at the Y, anything between the Y of the ventilator circuit and the patient connection is going to essentially increase your dead space, which is rebreathed CO2. So we've talked about that. So you really want to try to make sure that you minimize things that you place into the ventilator circuit between the Y of the ventilator circuit, which is here, and the patient. With the patient setup, we've talked about a little bit of troubleshooting. You're pretty much going to troubleshoot either a high peak pressure alarm or a low pressure alarm. High peak pressure alarm typically will be accompanied by a low pressure alarm. High pressure alarm will be accompanied by a low volume alarm. Typically because we've also talked about our control variables. So we have volume ventilation, and volume ventilation, volume is constant while pressure is variable. In pressure control ventilation, pressure is constant while volume is variable. We talked about how we trigger a breath, how we limit a breath, and how we cycle a breath. Remember, the trigger is how the breath is initiated. The limit is kind of the constraints with how much of the breath can be delivered. And then the cycle is how we basically end the breath. How can we transition into to exhalation? How do we end the breath from inspiration? We talked about the different types of triggers, the different types of control variables, as well as those limitations. So we've gone over that within the first little bit as well. Did just want to provide the overview. Remember, we stated that we had to have an operational verification procedure completed, which is basically, you may see that as a pre-use check, On the servo ventilator, maybe an EST, an SST, a device check, or an airtight check, depending upon which machine it is that you're using. But ultimately, the nuts and bolts so we've got internal mechanisms. So some of these machines will have an internal compressor so that in the event you lose your oxygen gas source, or you can at least ventilate with 21%. Some have backup batteries. Some of these ventilators can also double as what would be considered a transport ventilator. You can notice on this ventilator there is a place for us to attach a couple of oxygen cylinders, so that if we needed to utilize oxygen from the cylinder, we can do that as well. So that was just a quick overview of the actual box, and we'll get to touching the buttons and figuring out what goes on a little bit later. But we're just having our introductory piece of mechanical ventilation, and ultimately we've gone over, how a ventilator works, the components of a ventilator circuit, and so forth. And then next week we'll be moving into modes.